Okay, you see that sorry. Okay, you see the zone? It is not just after the blink. Okay? After the blink, you should look at this area, oval area for a toric cornea. This is very clear. The lens is good. You could provide the lens, but you have no tear film under the back optical zone of the lens. So you could have some contact there, and because you have a lens that is in this area is not well aligned, because maybe you have some toricity, the lens will move around all the time. What happens? That's the map we obtained. We obtained that. You can see here, we have an under correction zone. It's not really a central island, but it's an under correction zone. And this is created because we have some inflammation on the epithelial central cord. Because we have contact that creates inflammation, and that creates a small bump there that the topographer thinks that is a under correction zone. When you see on the topography differential map a zone of under correction, in my opinion, you should increase the sagittal height of the lens to create some space between the back optical zone of the lens and the cornea, around 5–10 microns is enough. But we need to do that. That's Central Island. That's real. That's a real case. Yeah. That's a real case.
On that last one.
Last one? Before? Previous one? Yeah. Yeah, go ahead.
And that lens is tilted.
Oh, yes. The lens is tilting, yes. And
Oh, I'm saying, you'll get different.
it's a bad feel, yes.
You'll get different areas of touch in the objects that
Yeah,
you
I don't stay there because we talk a lot on feeds today. So it's again the same. The lens is moving. Okay. The lens is rocking to the. I guess it's left eye. This one. Yeah, left eye. So it's moving to the nasal, and you could see more or less a little bit steep here, but in the temporal you could see that it's flat because the inner zone, the inner ring is strong and the outer ring. So it's clear that you have more pressure in this zone that is either the reverse curve, that and the edge. So you have the lens that is moving to the nasal, tilting, and creating this lift. So first assessment we have. Okay, let's go. First thing, central zone, touch. Alignment on nasal temporal is 2 feet. It is too steep here and too flat in the opposite. So why? Because the lens is moving. If we put the lens in the center, we will have equal lift, peripheral edge lift. So the landing zone in this area and this area is too flat. Too flat because here is too steep and the opposite side is too flat. Here the lens is touching and the opposite side the lens is rising like this. The lens is moving like this. So if you center the lens, you will have similar flat alignment. So horizontal is too flat, it's touching the center. Now, up and down, you see some green here and again here. Okay? So in vertical is as well a little bit flat. Not so much, but what we need to do here? Add the diameter. Diameter maybe is quite small. Okay. Again, Jeff. First, center. Second, alignment course for nasal temporal. Alignment course for vertical inferior. Third, total diameter. Okay. Right. Now we know. Well, we know what we need to do here. we need to increase the sagittal height of the lens in the central zone because we don't want touch. So the reverse curve needs to be steepened a little bit to secure the central zone. And the peripheral landing zone or peripheral alignment course needs to be steepened a little bit to obtain the perfect alignment all around. And the diameter needs to be a little bit larger to obtain the perfect corresponding cornea. So that's the thing we need to do. So looking at that, following the steps, we know what we need to do next. Okay, that's right? Jeff?
Well, it looks like the treatment zone is pretty well centered.
Oh, yes. But we have under correction zone.
Okay, but I'm seeing if the treatment zone is centered, then the lens is actually centering, it's just tilting.
Yeah. I'm going for your question, okay? Okay. If we follow this, if we just increase the sagittal height of... If we just separe the back optical zone to the cornea, if we increase the height little bit, we will obtain a centered zone, regular, patient happy, finished. Okay, but if we look at that, look at the blue ring. Blue ring tells you what is happening. What is happening is the lens is moving. This side is not taking any pressure here. Here is no pressure. All the pressure is created in this area. So you have a croissant image. I tell that the croissant. The croissant is when the red ring is you have, this is one, you know croissant, what it is?
A crescent.
A crescent. Yeah.
That dark, I think.
So you have, one is here, and you have the croissant like this, right? When you have the croissant, you have a pressure in one side and no pressure in the other side. You have a red ring here, but this is not, this is one, and this is the outer ring. Remember, two red rings that couple together at the end. So the inner red ring is this one, and the outer starts here, and will arrive like this. But it's not, because no pressure. Why is no pressure? Because the lens is tilting, arriving to the limbo area, and jumping over the corners. Not pressure at the end of the reverse curve. Okay? Sorry, the question?
So, from what you're saying, from your experience, over 50% of central eyelids can be fixed by increasing the sagittal.
Yeah, in my humble opinion, 100% of central eyelids. No, 99%. Okay, this is a tough point because books say opposite that I say. So the only thing I could tell you is that's my experience. That I solve that in this way, and I will show you a picture about that. But try for yourself. It's very easy. You have a central island. Try to flatten the feet. The central island will not improve. Will be worse. If you steepen the feet and you create separation, not touching the apical zone, central island will disappear. That's it. Try it. Yeah, it's not me. Try it. Okay, but I 100% confident. Okay, I'm sure. Yes.
So this is actually this way is fixed for like a called pseudo central island. Not
Sorry?
Pseudo, not the real central island. It's pseudo.
Well, yeah, it is not true. Yeah, exactly. Fake central island. Okay, John Longford, he created the patterns. Smiley face, frowny face, lateral decentration, central island, and fake central island. What? This is fake central island. Okay? But the central island that John Longford describes like a central lens, very stiff fit, I don't remember have any patient in my life. But maybe other lenses has that. Maybe other lenses has that. Maybe. So I couldn't assure that. But in my experience with my lens, never happened. Okay, but it's true. Fake central island. Okay, there's another question.
What you're trying to say is the central island is caused by an area of inflammation as the lens is rubbing up against it. Now, does this occur right away? Do you see this happen through time, or later this occur, or does it occur almost right away, is my question.
I'm not sure if I understood your question.
So how long does it take for this kind of pattern to form, is my question. So you're
Oh,
saying
1
that
week.
this is over a week you can see?
Yeah,
something
4
like that?
days you have it.
Okay, I didn't know whether it could be fine for, half a year, and then all of a sudden you can form something like this.
Okay,
See what I'm saying?
yeah, okay, I think I got your question. Okay, if you have staining, you should change your lens.
Okay.
That's it. Because staining means risk of infection. That's common. No staining, you could leave the lens and wait. Sometimes things will get better. But you should be sure that you have the healthy coating. Okay? That's very important. That's clear? That's a must. So that's an example. That's a fake central island. Okay, see? And this is an example. The upper lens here, you see that is too flat, at least in the lower area. You have contact in the center, or maybe not, but you have a different zone. Here, we flatten the feet, and this get worse, okay? This is, with two lenses, we have 14 microns. We have 14 microns of tear layer. So the lower lens has an overall sagittal height 14 microns less than the upper lens. So you create more pressure in the center, you have more touch in the center, and you create more inflammation. That inflammation, it converts to an irregular optical zone. What we need to do? Just look at the fluorescein. You need to step the fit. Okay? Then if you do a proper fit, you will solve that. Okay? But maybe if you want, we could call fake central island. Don't worry.
What did you use to change the sagittal height, which curves?
Oh yes. The easy way is to change everything. The easy way, in order not to feel so much, you change every curve for quarter diagonal. That's the easy way. That is 14 microns. The not so easy way, you change every small piece of the lens to obtain what you want. The programs help you decide. If you use Wave, iSpace, or Ortho or RGB, or any program you are using, you will control everything. So you could change anything you want, but you need to think what you are doing. Okay, that's important. So the easy way is to change everything, and usually it works. Okay. Okay.
So, how can you...
Sorry, by the way, it's the way we do with trial sets. When you change one lens from a trial set one step, you are changing all the curves one step. So it's the easy way. Then you could move to do a tuning. Okay, so sorry.
So that's okay, because it's kind of leading. So my question is how do you avoid this in the first place? Do you do a trial?
Okay.
So you look at your topography, you think you're doing a great, you take all your measurements and everything, and then...
Stop to do
just...
Okay, that's a question that someone asked me in the break. The thing I do is I had all of us are trying things. So in the past I worked by trial sets. Then I moved to empirical, and then I moved to trial set plus empirical. So at this moment I am again in the trial set plus empirical. So I calculate the lens using the topography data and so on. I choose from my trial set the most close lens. I place on eye with the fluorescein in, always from down to up, okay, to avoid bubbles. Then I have a quick look, I wait, another, after 3 minutes, I decide if this lens is right or not. I replace the lens or not. If I replace the lens, it's another new for trial set, 1 step or 2 steps or so on. And after that,
Do the Ortho-k prayer.
exactly. And after that, yes, I order the final lens. So even I don't release the patient 20 minutes in the waiting area, but I strongly recommend at the beginning to do that. And after that, do the first overnight trial. But when you have some experience with the fluorescein pattern after 3-4 minutes wearing, you are ready to say, okay, you could wear this lenses overnight or not. You don't need more steps, but at the beginning, it's strongly recommended. Leave for 20 minutes, look the fluorescein again after 20 minutes, look the topography map in the differential to see the centering, the issues and so on, look for health and so on, every step at the beginning. But after that, you could move on and make the things quicker. Yeah? Okay. That's, you know that's when the lens, that's a problem when the patient is not taking out the lens properly. The 50% of the results of Ortho-k is patient management. 50% is fitting, 50% is patient. So what I do, because people don't remember orders, and just keep, for example, in theory, from all the things I told you today, you will only remember 30%. That's theory. That's because you are very smart, very concentrated, and I repeat the same thing several times.